Okay, so I had a student ask for help on computational models using WebMO. And so what I'm going to do is open up the lab. I'm in dark mode, so yours is probably white, right? But anyways, I'm going to just open up the lab and read these instructions and walk you through it. First thing I'm going to do is I'm going to go to webmo.net and I'm going to log in using a guest, login and password, right? So I'm going to come here and I'm going to go WebMO login. Oops, spelled login wrong, but somehow it knew I wanted that. Looks like guest has already been populated, so the username is guest and the password is guest. And while I'm waiting on that, I'm going to come over here and read the next instructions. And it says, all right, now we need to go to the build molecule window. I'm trying to go fast here because I don't want to build molecule window. I don't see a build molecule window. Did I read that wrong? We're going to click on new job. Does it say that somewhere? There you go, new job. Yep, click on new job, create new job, and then build molecule window. This is the build molecule window. So the first molecule I'm going to do, I think, is water. And the way I'm going to do it is I'm going to, here's my build molecule window, click on the periodic table here, which is here, click periodic table. And let me go back over to the instructions. And the instructions say, build one atom at a time. All right, so for what I'm going to do is I'm going to come over here and click oxygen because I'm doing water. And there's my oxygen model. Then I'm going to come back over and click hydrogen and hydrogen. And to make a bond there, I'm going to click on one of them and drag, and click on another one and drag. Okay, so I've made my water molecule. Now that I've made that molecule, let's go back over here to the instructions. Oh, it says I've got to click here next, okay? So I click here next, and it says, when you get here, choose Gaussian. It doesn't show that drop-down menu there. Thank you, dear. It doesn't show that drop-down menu, but I'm going to do it over here. It says choose Gaussian. The instructions say that. Okay, now that I've got that, I click to the next window, and then the instructions say, name this something different. So I'm going to go H2O, GO for geometry optimization. It doesn't really matter what you name it. Just make sure you know what you named it so that you can go find it, right? And the calculation we're doing, these are in the instructions, the calculations that we're doing say do geometry optimization. There it is right there, right? So I'm going to go here and go geometry optimization. And it says for the theory, choose AM1. So I'm going to go here, and AM1 is pretty far down here. I'm going to click AM1 right there. And then it says ignore the rest of these, okay? So I've got that. And I think I just submitted it. So this is my thing, and it's running over here. Can you see it says running in yellow? It's about to be done, though, because it's a fairly small molecule. And it's going to go, yeah, you're done. Right? Look at that. Boom. Done. Okay, so I'm going to click on that. And I'm going to go back over to my instructions. Okay? And my instructions say, now that you've done that, what you want to do is you want to come over to the arrow tool. Oh, that's not the arrow tool. Does it? I think it says I'm not sure. Running. I don't think I can do. Maybe I can. Maybe that's enough. Yep. Yep. Sure enough, that's it. Okay. So it says click that arrow, which I did. I clicked one atom. Then I'm going to click another atom. And after I've clicked two atoms, it tells me the bond length right here. Right? And my bond length is 0.961 angstroms, right? And then after I click a third atom, it's going to give me an angle. And there it is, 103.607. And I think I'm done with that portion at that point. Let me go back over to the lab. Let me go back over to that lab. Do I have that open? I don't think I even have that open. Okay, so I can't show you the table for that. I don't want to take the time to go open that up right now. But we've got that done. We write the bond length in there. Now, if you're not sure about that, you can unclick things too, and you can go, okay, I got that. There's my bond length is 0.961, and I click the third atom, and it gives me a bond angle of 103.607. All right, so let's go here to, let's say I'm done with that, and I'm going to go to File, New, and I'm going to do another molecule. So let's come back over here and see what's the next molecule that I'm going to be doing. I don't think I have the list of all, I don't have the list of all the molecules here. So let's say the next one is ammonia, NH3. Let's click here and boom, hydrogens. I'm going to click here and then I'm going to click and drag to that. I'm going to click another one and click and drag and click another one and click and drag. Okay. Now I'm going to go to, I've built it. It's not pretty, but I've built it. Now I'm going to click that. Gaussian's already selected. Click over here. AM1 is already selected as geometry optimization. I'm going to go GO for geometry optimization. Click that. And here's my job. It's running, right? Or it says it's queued. It's not quite running yet. But it'll be running here in a second. And it's running now. Oh, wait, it's done. Look at that. Look how fast that was. So this is my H3NG. Let's click on that. And I'm going to come here. I'm going to turn this around a little bit. Is that right? No, it's planar. That's really weird. I don't think that's right. I don't think that's right. It did not do a very good geometry optimization, is it? So let me check it again. Well, let's try it. Okay, so bond length of 0.977 and a bond angle of 120. Okay, so write that down in your sheet, in your lab, and then say, is this what you expected? And I'll give you a hint. For ammonia, this is not what we expected. But that's what you got, right? That's what the tool gave us. So if we want something better than that, we have to make some adjustments to the tool. That's not what we're doing with this course, with this lab, but it's actually not that difficult. And if you're curious about it, I hope you'll ask me. All right, hope that's helpful.